And good afternoon to all our guests. Good afternoon and good morning to those who are joining us from the US. And welcome to this session, which is talking about the future of LPG and new fuels. One of the things that we've not really touched on that much on this Congress is that the Paris Accord that really set a lot of our activity in the regulation up, linking into RED 2, was the agreement that was set in COP21 in 2015. And the reason I raise this is because that's talking about all these endeavours as we move into the new renewable world, all these endeavours trying to cap the temperature rise by 1.5 degrees by the end of the century. We talk about 2030, we talk about 2050, but these are effectively trajectory lines for us moving forward. The path that we are on will never end. It's about trying to protect the climate, it's about trying to decarbonize, but also it's about trying to have a sustainable business as well as a sustainable environment and create sustainability for all our stakeholders, especially our customers. We have to take the best knowledge we can from insiders, people within the industry, and very importantly, from those people who are on the edge of the LPG industry, but they are effectively operating in other wider areas of the energy world. What will the mix of energies look like, and how will LPG transition to that point? And indeed, will LPG end up on the future table, not as a transitional fuel, but as in renewable form, as an actual fuel that we need all the time as part of the mix? What are the substitutes for LPG? Again, we have to maintain sustainable businesses, and we need to be flexible and agile enough to realize that we also may need to adopt and embrace other molecules that enable the sustainability of business and enable us to move through the maze of opportunity and threats that come up for us. How will population and economic growth change that could impact LPG? These are the sort of questions that we need to address. We've already touched on what one could call the holy grail of the future, which is hydrogen, and how will that play out in the future as we move forward. And so I offer no apology for the fact that we will be touching on things that have already been brought up in the Congress. And the reason I will offer no apology is because it is so important that we look at these challenges from every single aspect, using the wisest minds we have both within and outside of the industry. So with that, what I'd like to do is to introduce our very four wise men, if I may call them that. We have professors, we have masters, we have doctors, and I'm humbled and honoured that these gentlemen will give us their view in looking at LPG, future fuels, etc. We will start with an internal view. I may introduce Cedric Caudron. Cedric has a master's degree in mechanical engineering, production and business. He has lived and worked in Africa, in the Middle East on some huge projects before joining UGI. He's also operated in France, and he is a pillar of our business and strategy development. Recently, he's been doing work on what we have been calling the energy transition pathway. He is a highly valued officer of UGI International and a highly valued colleague of mine. So at that point, I shall hand over to Cedric to give us his view and interpretation of the transition that we're now all on. Thank you.
Thank you, Neil. It's an honor to work with you, and it's also an honor to be there virtually with you on behalf of UGI. For over 135 years, UGI has been supplying energy to the world, and we have been a player in the development of our society as we know it today. I personally joined UGI 16 years ago. It's the age of my daughter. And what I can say is that our industry is constantly evolving. However, what is happening now is more than an evolution. It is a new step. And with our energy transition pathway, our UGI roadmap to 2030 and beyond, we are embarking on a new chapter, a renewable chapter. On this slide, I will maybe echo some of the presentation and topic presented yesterday and today earlier during the Congress. I simply want to insist on the environment we are in today and the importance of taking the necessary action. There is no doubt the climate is changing and we have a role to play for our customer, the community we serve, and our employee. Many recent initiatives to change energy policy have been led by the effort of individuals and pressure from specific stakeholders. Renewables are now at the forefront of the EU policy, just like Fit for 55 package, for example. And more of that, they are embedded in COVID-19 recovery plan at the national level. Countries, cities, and communities are developing projects to supply energy locally to enable greater sourcing control. Individuals are educating themselves on action which could be taken to avoid climate change. And no, it's also supported by the US administration, which is back in the Paris Agreement. So we need to change. We need to change to be part of the energy mix of the next decades. The next step will be even more ambitious when it comes to achieving carbon neutrality by 2050. But entire sectors will be difficult to decarbonize, such as off-grid customers, and it's important to leave no one behind. At UGI, our ambition is to reduce the carbon footprint of our energy product to meet 2030 target. And at the same time, we are setting the foundation for a 100% carbon neutral future. On my next slide, I would like to insist on the LPG market. LPG covers today the eating needs of more than 20 million EU citizens and 700,000 businesses, essentially in areas where the natural gas network is not available. Autogas fuels a current fleet of over 8 million vehicles and a network of 32,000 stations across Europe. And a large proportion of businesses and homes that use fossil energy sources have processes, heating, and beyond that cannot be electrified. This is a significant barrier to the green transition and thus a challenge to achieve the EU ambition. LPG and renewable liquid gas, if I may, are an effective way for this consumer to reduce carbon emission, as it is possible to gradually increase the share of renewable liquid gas without expensive retrofitting or new installation. At UGI, we serve many of these off-grid customers, residential, industrial, agricultural, and they cannot so easily decarbonize. They rely on us to provide a cost-effective alternative to their current supply of LPG. And a renewable liquid gas solution could reuse a significant part of our existing assets and be quickly implemented to serve our customer. So that's why we have developed our energy transition pathway. And as you know, bio-LPG is not available today in large quantity. And in order to allow us to continue our activity, our distribution activity, without being involved. So it's key for UGI to be involved in the entire LPG value chain, and especially today in upstream activity to ensure adequate sourcing. This implies transformation topic, but also a big lobbying effort to get the potential of renewable LPG recognized, and thus to promote its production. At UGI, we are looking to develop a soft transition toward production, co-production of bio-LPG, on-purpose production of renewable DME, and later on, production of propane and butane directly. That could be quickly implemented and help reducing CO2 emission. It will allow us to take advantage of our existing distribution network, since renewable LPG or ADME does not require any changes. Handling and delivering capabilities are really similar. There is a limited need to modify existing infrastructure, and we have blending possibility with fossil LPG, or it can be sold as a pure renewable. It's also a drop-in solution for a customer with accessible price compared to the other sustainable alternatives. But it's a bumpy road that needs support. Bio-LPG represents today a limited share, and on-purpose route economical attractivity will be increased only if policy support of LPG end use were equal to other, like mobility, for example. As one of the European leading distributor of liquid gas, not only we take responsibility for selling and distributing renewable alternative, we also take responsibility today for developing and producing these renewables. And by producing sustainable low carbon liquid fuel, we create a more secure supply chain that we own hand to hand, meaning that we will constantly be able to live up to our customer expectation. In terms of technical pathway, if I may, to reach our 2030 goals and beyond, we have developed an innovative roadmap built on a mix of technologies. There is not only one. Some of them are available today and capable of co-producing LPG. And for the next step, we are focusing on in-development technology to produce on-purpose liquid gas. We are also intensifying our focus on research and development and external partnership. Our pathway will be an iterative process where we constantly search for new innovative and efficient way of producing renewable liquid gas. This is the most appropriate way for us to innovate and make our future sustainable. The future is a smart combination of technology, partnership, and feedstock availability. As we are targeting carbon neutrality, we have to use what is available annually. It is simply what nature produces over a year and qualified as biomass. One of the most abundant components in biomass is sugar. This is what photosynthesis produces using water from the soil, CO2 from the atmosphere, and the sun ray. The fermentation of sugar produces alcohol, and given the limit of the HVO process linked to the ban of palm oil or the limitation of used cooking oil, it's obvious for us to focus our work on the conversion of alcohol into hydrocarbons. We can use different feedstock, but we target advanced material in the sense of the European regulation and especially RED II and Appendix 9. That is to say, essentially, what is not in competition with food or something that will introduce change in land use. The transformation of alcohol to jet or gasoline have been around for years. Each step are well proven and understood at commercial scale. There are many projects under development that focus on jet production with ethanol as the initial feedstock. One of our partners, EcoBenz in Poland, has already mastered this process on a pre-commercial scale with a production unit of 22,500 tons per year. EcoBenz is targeting the production of advanced gasoline as a drop-in solution that could be blended up to 80% with standard gasoline. It's definitely a promising pathway that is proven to co-produce bio-LPG, and in that case, up to 15%. This partnership is illustrative of our leadership in supporting emerging technology that have the potential to transform and decarbonize our industry. Among the other pathways, the most mature one, I would like to mention renewable dimethyl ether, RDME, produced from organic matter. It's a sustainable liquid gas with up to 85% lower greenhouse gas emission compared to fossil alternative. RDME can be produced from sustainable feedstocks such as waste and residue using gasification and catalytic synthesis. Being a safe, cost-effective, and clean-burning fuel, RDME is a viable and sustainable addition to the energy mix. RDME is chemically similar to LPG, and in both pure and blended form, RDME can help the decarbonization by becoming a sustainable alternative for off-grid energy uses, including heating, cooking, and transport, just like the existing uses of LPG. Together with industry partner, we have announced earlier this year our ambition to promote RDME, and we are investing in the development of 6 production plants within the next 5 years, targeting a total production capacity of 300,000 tons per year in 2027. Our ambition with SHV Energy is to build a joint venture, and this joint venture will bring scale and critical mass to the RDME market by developing opportunities for investment in production capacity. Moreover, it will promote the use of RDME by driving effort for market acceptance, developing new RDME-based technology to gain traction among users, and supporting the development of infrastructure, regulation, and standard for the safe use of RDME in the off-grid sector. This is really a great step forward where 2 leaders team up to innovate for the benefits of our entire industry. The future is certainly in the recycling of what we have released in the atmosphere for decades, even centuries. By recycling the CO2 that is in the atmosphere, we have a technology that could be considered neutral, as long as we do not release more CO2 in the atmosphere. This is, in a way, what nature does with photosynthesis, removing CO2 from the air for plant growth. Numerous projects are underway to capture CO2 at the time of the emission on the industrial production site or directly in the air. These projects are called Power-to-X. The first production site will be operational in the next 2 to 3 years, initially with an e-methanol production. And methanol is an intermediate of interest. It's an alcohol, and it could be helpful for the synthesis of gasoline, propane, and DME. All the development are underway to develop an artificial photosynthesis to produce sugar or oil like nature, but in an artificial manner. This will indirectly multiply the available biomass volume for biofuel production, but we speak here of medium and more long-term projects. What's next? To go further and look at the long term, we certainly have to think about our diversification with less carbonated molecule. The possibilities are multiple, but some of them have a particular fit with our industry DNA. Let's imagine that we go from 3 and 4 carbon atoms to only 1. We now have a candidate, that is methanol. I mentioned it already. It represents an interest as an intermediate molecule, but also as a final energy. The green methanol market is expected to grow strongly by 2030 in Europe. Expert predicts that 54% of methanol in Europe will be bio-based or renewable by 2030, with a volume of over 500,000 tons per annum. Transport is expected to be the key driver. There is already interest across the whole value chain, with a wide range of players starting to invest, like producer, distributor, car manufacturers, shipping company, energy company. Methanol to gasoline and DME production shows the immediate interest of methanol for industry. And in the longer term, it's being considered as a transportation fuel for fuel cell vehicle, marine transportation, and gas turbine power generation. Let's now substitute the remaining carbon atom by nitrogen. We now have ammonia. Ammonia is currently used by a vast array of industry, fertilizer, chemical, mining, pulp and paper industry, and other. Green ammonia production is expected to reach 1 million tons per annum by 2030, and 22% of the total ammonia produced annually will be renewable. A wide range of companies has expressed interest in green ammonia with new uses, mostly in the power generation and maritime sector. Most technology are still in the development phase, except for production, which is expected to reach commercial scale in the mid-2020. There are emerging applications under development, such as energy carrier for hydrogen. It's more cost-effective compared to hydrogen for long-distance transport and storage. There are, however, many key challenges to address for this to happen. Among them, we can mention conversion efficiency, cost competitiveness, health and safety, public acceptance, NOx emission, and so on. And finally, just keep the hydrogen atoms. We now have a molecule that does not contain carbon anymore, and that will not produce greenhouse gas emission at the exit of the exhaust pipe. But what about the production of this hydrogen that is not yet completely decarbonized? Today, hydrogen mainly comes from fossil fuels such as natural gas. With an expected annual growth of 13% from 2020 to 2030 in production, renewable electricity should represent 20% of the total hydrogen produced in 2030. This will depend mainly on a decrease in the production cost of renewable electricity, but also on the cost of the electrolysis, as commercial scale installations are being set up. Green hydrogen projects are booming in areas where we have regulatory incentive and where renewable energy can be produced at low cost condition. Mobility is expected to represent nearly 50% of new usage of green hydrogen by 2030, But gas grid, building, and microgrid after 2030 could represent the main growth. Finally, I would like to open some window for different areas of innovation. Innovation, as you can see, is on its way. And for the future, there are many other areas where innovation are needed. Propane and butane production has never been a refiner primary objective. In our discussion with them, they clearly tell us that they try to reduce its production as much as possible. There is a need for our industry to promote and support the development of on-purpose propane and butane production processes. It is also necessary to ensure that the efficiency of production processes is improved. These processes must maximize the amount of energy obtained with the unit of raw material of feedstock. Another challenge as we turn our back on fossil fuel is to ensure the availability of feedstock to produce liquid biogas. The quantity are by definition limited. It is just a question of designing system in loop in a circular economy, which make it possible to recycle waste to reproduce again energy. One of the energy of the future is the one we do not consume. It's all about energy efficiency in order to consume better and waste less. The production of renewable energy is expensive, so we need to consume it better in order to reach a balance between energy production and demand more quickly. And this is the ambition of the energy efficiency target within the Green Deal. And finally, this will be my last word. We must be open to all types of partnership. The issue of recycling, defossilization, or greenhouse gas emission reduction concern multiple sectors and not only energy. It's time to work together.
Thank you very much, Cedric. That's a great start for us. I'm conscious of time, so what I will do is ask one question for you. Please ask questions in the audience, and we'll try to get it at the end. So my one question is this. We have been talking on the Congress a lot about new molecules, innovative ways of bringing materials, new materials to the market. But I get the sense that we haven't really focused that much on energy efficiency, as you mentioned in your innovation summit. Do you think that's something that we should address more? We should have more of a focus on it? Because if affordability is a concern of us, we're talking about very expensive pathways looking to the future. Do you think the first fuel, i.e. not using it, is something we should focus more on?
Yeah, you're completely right, Neil. And there is two pillars that need to be working parallel. The first one is renewable, and we have been able to demonstrate that we can produce renewable liquid gas. The second one is efficiency, is really how to reduce the demand. And you can start by reducing your consumption, by insulating or using more efficient heating equipment. And then you can introduce a notion of control, of measurement with real-time data on the use of energy. To go further and go beyond the consumption side, efficiency, it's also about the management of the supply with an increasing dependence on renewable energy. By definition, renewable energy, solar and wind, is intermittent. So you need to manage this. It's part of the efficiency, and it could be storage capacity, conversion of this energy to something else. So there's many topics to address in this pillar too.
Okay, thank you, Cedric, very much conscious of time. We will now go to our next speaker, Dr. Walt Hart. Walt has got a fantastic background in terms of experience. He is the Vice President of Strategy and Business Development for IHS Markit, covering basically the globe, Europe, CIS, and Africa. Dr. Hart has a specialism in petrochemical feedstocks and in NGLs. He has worked for companies such as Dow Chemicals, Owens Corning. He has Bachelor of Science, he has a PhD, he has an MBA, he supports the Women in LPG as an ambassador. Walt has a fantastic understanding of the portfolio of energies that we use, liquid energies specifically and especially. And I would now like to welcome Walt to address us with his insights into the future and where we think LPG will play a part, or maybe not. I mean, it's all about being honest and socializing the reality. Thank you, Walt.
Thanks, Neil. It's a real honor and a pleasure to be able to speak to you today. And let's go straight to the agenda, which should be the next slide. Good. And so, when we first talked, Neil, we talked about looking at some of the challenges and among the pathways to renewable LPG. And so I've really tried to focus the attention of the presentation around that. And so that starts with the oil and gas outlook. So we'll start there. And then I'll focus on several of the pathways that are the obvious pathways, many of which Cedric talked about. And then there's some financial considerations that are important to consider, which Cedric mentioned and perhaps didn't dwell on so much. And then we'll look at the implications of this. What does this mean for the LPG outlook? And then finalize with some closing thoughts. So with the next slide, we'll go straight to the oil and gas outlook here. And as you know, probably 100, and I think at last count I've seen maybe 139 or 40 countries have announced net zero plans by 2040 to 60. And if you look down at the bottom, the retail industry response, which I'm sure you've heard over the last couple of days, is that we want to try to go to renewable LPG. But the alternative question is fossil LPG going to disappear? And the answer to that, I can tell you, is no. And the truth of the matter is that most LPG, nearly all LPG today, comes from two sources. One is from refining, the other is from gas processing. And you see here the forecast that we have, the long-term forecast for global refined product demand on the left and natural gas demand on the right. And so indeed, refined product demand is leveling off. And so by around 2040, we should peak out on refined product demand. And that will impact the amount of associated gas. So both the LPG from the refining itself and from associated gas is going to be impacted by that, and ostensibly would level off, but there's some caveats around that. Now, in the meantime, you look down, you say, well, global natural gas demand is not going to level off until much later. And, it's a lighter fuel, it produces less carbon, and so it's going to continue to increase longer. It should level off, but closer to the 2040s rather than the 2030s. So the non-associated gas is going to have to increase to meet natural gas demand. And even though non-associated gas has less LPG than associated gas, it still has a lot of LPG in many formations. And so we're going to see increases in LPG from non-associated gas. Now, and the overall effect is that LPG production, as you'll see later in a later slide, is going to be increased through about late 2040s, probably. So another impact is that butane demand. So gasoline demand is likely to end by the end of the decade, and and at least level off, rather, not to end completely. But what that means is that butane demand from refineries is going to peak, and that's going to liberate more butane for the market. So that's one example of a side effect that you probably haven't heard a lot about. Meanwhile, plastics demand, polyethylene, polypropylene, and the like, is likely to increase apace. It's not likely to level off, and it has a 3 or 4% growth level for both polyethylene and polypropylene. And naphtha is a major feedstock for that. It's responsible, for example, for about 40% of the ethylene produced. And what that means is that, and 85% of naphtha comes from refining. And so that means that naphtha yields in refineries are going to need to increase to be able to meet ethylene feedstock demand, or ethylene feedstocks are going to have to come from other sources like LPG and ethane. And so the issue there is that if refineries are going to increase naphtha demand, that's likely going to have an impact on LPG yields as well. So it's possible the refineries of the future are likely to be producing more LPG, and that's fossil LPG, than what we've seen in the past. Another potential disruptor is the trend toward producing chemicals directly in refineries, traditional refineries, switching over for so-called crude oil to chemicals. And that could very well produce a whole lot more fossil LPG as well. So we should expect to see large changes in the traditional refining and gas production that's going to end up still producing a whole lot of LPG, and we should not see it decrease. So in the next slide, you've heard a lot about HVO. I'm not going to go into huge detail. One thing I'll point out, this is from Total. You see in this particular graphic, it's maybe a 4.5% yield to biopropane. But in what we see, we estimate variously whether you get roughly 7 to 10% as a yield. You get more if you're trying to produce biojet rather than renewable diesel. But there's a couple of things to point out that are important. One is that you only get propane from the HVO process. You don't get any butane. So anything that's butane specific from a demand standpoint is not going to be served by this HVO process. The second thing is that renewable diesel is different than biodiesel. Biodiesel is produced from transesterification, which has glycerin or glycerol as a side product, and it doesn't produce any LPG. Third thing, different types of oils or lipids produce, can affect the propane yield. The lengths of those side chains, for example, will have an impact on the LPG yield coming out this. So there's no exact yield to say. And then finally, you can also use what's known as tall oils or other fatty acids to feed the HVO process, and that won't produce any propane because they don't have that backbone that comes together. And so there are limitations, and so you need to watch this when you're looking at HVO and see what kinds of feedstocks are being used. If we can go to the next slide, we've seen that there are several renewable LPG pathways that are commonly referred to, and Cedric mentioned all of these. The first one on the left, power to X, biogas conversion in the middle, which is typically going to go through gas to liquids. And on the right-hand side, biomass to liquids, right? And so what these have in common is that they go through synthesis gas or syngas, which is a mixture of carbon monoxide and hydrogen. They all have their own individual challenges as well. So if you look at power to X, Cedric mentioned this, first is, where do you get your CO2? And the second thing, though, is that it's going to require a lot of hydrogen. And that hydrogen needs to come from sustainable sources. We're going to hear a lot more about, hydrogen in one of the speeches ahead, and hopefully they'll talk about the different colors of hydrogen and talk about that. But if you really want to be sustainable, it needs to be green hydrogen. Secondly, if we look at, and the other thing is that when you're trying to make CO2 turn it into other types of fuels, that is effectively thermodynamically uphill, and you're going to need a lot of energy input to bring that to come to fruition, and that's expensive. When you look at biogas conversion, what I'll point out is that, you have, when you look at biogas, it's a mixture typically of methane and carbon dioxide. So there's a lot of carbon dioxide that's involved in that process. There's different types of biogas, and you're going to have to make a separation. It's not as clean as getting as a lot of the methane that you might get from the gas grid. And the other thing I'll point out is that biomethane is going to be in high demand. And the gas market is much, much larger than the LPG market. People are going to be looking to use that biogas. It could become quite expensive. On the right-hand side, BTL is going to be, basically it goes to syngas via incomplete combustion of carbon-containing materials. And the thing about any kind of XTL process is that they're quite capital intensive. And then, when you're using dirty feeds, there are going to be a lot of pre-treatment that's necessary. And so, if you're going to go to that kind of trouble, you want to make sure you get a lot of return for it. So what is the issue with synthesis gas? Let's go to the next slide. So in the next slide here, you see synthesis gas, and you look on the left-hand side, what's really amazing about synthesis gas is that you can go to an amazing array of different types of chemicals from it. When you look at the process that goes through alkanes, typically they're optimizing on diesel and gasoline. And indeed, if you look at, say, Sasol and Shell, you're looking at maybe a 1% or less yield typically, because they're trying to emphasize middle distillates, gasoline, things like that. Can you shift the optimization? Absolutely. You can change those operating conditions. I won't go into the details of this, but you shouldn't expect them to. And that's really for financial reasons. So I'll talk just a little bit more about that on other slides, but anything that goes through synthesis gas is unlikely to produce a high yield of LPG because other products are going to be more cost effective to produce. Next slide, please. You also heard Cedric talk about production through starting with ethanol. Now, the thing I'll talk about there, and I won't go into a lot of detail, but first off is that actually you don't have to start with just ethanol. You can use other types of alcohols for this. But what's important to understand is that, in Cedric's graphic, you saw that it goes through ethylene. So ethylene is also something that people are going to want to produce in sustainable and bioeffective ways. And ethylene traditionally has been more expensive than LPG. And so if you're going to go through an alkene like ethylene, it's going to be more valuable than LPG. So it's not going to make a lot of sense to be producing LPG if you have alkenes as an intermediate. And so consequently, there's been a lot of research to optimize the middle part of this, the oligomerization, where you go from ethylene and other alkenes to longer chains, to optimize on those middle distillates and to produce very little of the short chains. It doesn't mean you can't do it, but if you do, you're giving up a lot of the value that you potentially could have. And so you can see on the bullet on the right-hand side here that there are certainly processes out there that can use that can really minimize the amount of LPG that's produced. And you should expect that that's the way that most of these processes are going to go, and that the LPG production is going to be small. Next slide, please. So this next slide is, this is from a company called GEVO. It's not an endorsement by IHS, but I just thought I had a good indication in their investor presentation from March. And so with the little blue arrows, I'm pointing out a few things. One thing that Cedric mentioned is that they want products, their customers want products to be drop-ins, so they can use existing infrastructure. The second thing is that their customers want to have their products at a price that's near parity with the fossil fuels, especially to start off when they're trying to convert the processes over. So there's a lot of price pressure on these companies, these biofuels companies, to keep the costs low. And then the last arrow that you see here is that GEVO is trying to share their carbon value to be able to make the products more affordable for the customers and then to be able to eke out a return for their own company. There's a lot of margin pressure on this. You can see here, they build the molecules that capture the most value. Most of the time, that's not going to be LPG. And so on the next slide, the implication of this is that an economical, on-purpose renewable LPG process would be quite a disruptive technology. In all the cases that we've seen, it's a byproduct, just like LPG, just like fossil LPG is today. And the qualities that make LPG attractive as a petroleum byproduct, in that it's cheap and plentiful, make it unattractive to make on purpose. So what are the criteria that we need? You need a bio or sustainable feedstock that's cheaper than the bio LPG being produced. And that cuts out a lot of options, a lot of pathways. The feedstock would need to be in sufficient supply. It needs to be sufficiently plentiful to avoid triggering a restrictive increase in cost if you happen to start using it in large scale. It needs to make more sense to make bio LPG than to move on to other biochemicals or biofuels, which is a problem with going any kind of through an alkene on the pathway to LPG. So that cuts out a lot of different processes. I'll skip over the glycerol part of that, and let's just move on to the next slide, just in the interest of time. So what would it take, to produce more bio LPG, and is it really worth it? So on this graphic here, on the left-hand side, we have a simulated Shell gas to liquids barrel. And so today, they're not producing much LPG, as I mentioned, in the 1% range. And so what are they producing? They're producing naphtha, they're producing diesel, and they're producing kerosene. And as I mentioned, you can shift that equilibrium, but would it make sense to do it? So on the right-hand side, this is just pulled some wholesale prices from April 2021, and you see, why is it that they're producing these products? It's because they're worth twice as much as LPG. That's why they're doing it. And so you might say in the future, well, geez, LPG is going to become more expensive, but these other products will too. And they're going to become more expensive because they come from biosources and because they're drop-in products that go into the existing infrastructure, just like you want to do with LPG. So is it likely that the LPG is going to outcompete these others? I would say probably not. So let's, what does all this mean for the LPG forecast going forward? Let's take a look. Next slide, please. So on the left-hand slide, you see our outlook for just the HVO biopropane production. And what you can see is that we have it coming to around 6 million tons by 2050. Now, I'll say this is an uncertain forecast. We might get more biojet that's produced by this process. You might see more renewable diesel produced. But even if we're wrong by half, it's not anywhere near what you need to be able to supply the world's LPG needs. On the right-hand side, you see our overall LPG forecast. And so the renewable LPG is the red sliver on the top, which is probably less than 10 million tons. And even if we're wrong and it's 20, it's still nothing like like what we're going to need for demand. But you look down on the bottom, this is all the fossil LPG. It's still going to be around, and we're going to have to do something with it. Consider that if Europe is not going to use it, and the US is not going to use it, and Northeast Asia is not going to use it, and Brazil's not going to use it, and South Africa and Australia are not going to, where's it going to go? Somebody's got to use it. And so the thing to consider is, what is the real opportunity here? Is it in the sliver of red at the top, or is it in the 330 million tons of LPG that has to find a home going forward? Just something to consider going forward. So next slide, please. One path that I don't really see talked about a lot, because this is kind of not a chemically oriented audience, is you hear about pyrolysis, which is kind of the gasification of biomaterials, but everybody wants to get rid of waste plastics. Universally, people want to get rid of waste plastics. And there's certainly mechanical recycling, but on the lower left-hand side, you see chemical recycling. And one thing you can do is going through a thermal depolymerization process, which is a form of pyrolysis. You can produce, you can chemically recycle certain types of plastics. Now, certainly there's some challenges to it. Historically, it's been uneconomical. It's very energy intensive. Contaminants are an issue. It takes a lot of pre-processing. But the thing to consider, though, is that while the target may be to produce monomers, you may also get some side products like LPG. And I don't think there's any clear winner yet about which processes and which catalysts, et cetera, are going to be used. But it's very likely that we should see some LPG, some sustainable LPG come out of this process. So that's something to keep forward to, and I think a glimmer of extra hope. So let's go to my last slide, which is just a few closing thoughts. So, the first thing is, it should be obvious, both from what Cedric said and what I said, is that with the technologies currently be considered, renewable LPG is really a long way from meeting potential demand, not just here in Europe, but all over the world. Secondly, is that an economical on-purpose renewable LPG production process would be quite the disruptive technology. And so, the qualities that make LPG attractive as the byproduct make it unattractive to make on purpose. And that's a disadvantage. Biofuel and chemicals producers are not likely to optimize to LPG because it's a low cost intermediate. They're going to be looking to produce higher valued products. Now, byproduct fossil LPG is going to continue to be produced. It's going to be in large quantities. We're going to have to find some way to use it, even if it's not in Europe or other markets that have committed to net zero. There's a big opportunity there. Somebody's going to have to deal with that, and it should be an opportunity for retail companies because they already have the infrastructure and the know-how about how to deal with it. And I'll say every company with material exposure to LPG should be developing a strategy right now, particularly if you're a small retailer. You need to really understand where you're going to get your supply. So I will leave you with that, and I really appreciate the opportunity to be here. Thanks, Neil.
Well, that was tremendous. In terms of the synthesis in your mind of how these all the molecules can interact from a value point of view, from a feedstock point of view, 20 minutes just doesn't do it justice, but it's made us think. If I was to ask, if you were to give one message to the industry And again, I do appreciate that this is a bit of a tight question, but what would your message be? What would you say to the industry from what you know?
What I would say is that the industry should look at the ways that it can serve, the LPG in the future. It's one thing to look at a lot of these other fuels, but there's an awful lot of fossil LPG that's around, and you need to be able to look to see if you can really come up with enough renewable LPG, if you're really able to source that, because I don't see a lot of the retailers moving upstream into sourcing. And you really need to maybe consider what your strategy is to see if maybe you should be following where the fossil LPG is going to go because it's going to be produced, or whether you really need to focus on that renewable LPG. Consider what your strategy is.
Great. Thanks very much, Walt. Just for the interest of time, I'd now like to introduce our third guest speaker, Dr. Anjay Sakura. Anjay is the CEO and president of Energy Studies Institute. Again, a tremendous breadth of experience. Anjay has worked for PK Olin. He's helped to the optimization of the company's production assets. Anjay is a visiting professor, has been a professor at the SGH, well, he is now the visiting professor at SGH Warsaw, and he was the assistant professor at the facility of drilling oil and gas. So he's been in the banking world, and I could actually take his 20 minutes introducing him, but I won't do that. The point is that Anjay also has a lot of experience in NGLs and hydrogen, and he will be giving us a presentation which is basically saying, okay, what next? Which leads very nicely on from Walt's assessment that the future, there's some challenges, there's some sensitivities, and there's a lot of complexities. Anjay, I'll leave the floor to you. Thank you.
Thank you very much indeed. And it is a great honor and pleasure. Once more, thank you very much for this beautiful introduction. But what I would like to do, being a little bit, as you said, closer to universities, I would like to take this 15-20 minutes opportunity to take you on a journey because of energy. And the slide with the title of my presentation is because of natural gas liquids, hydrogen, and as you said about the future. I'm underlying this because our hosts, we could share my document published with my colleagues a few weeks ago under the same title, where we could address not only the problem because of natural gas liquids and propane, butane as a part of the story, but as well the few sentences concerning how to store, how to prepare those raw materials for us. Excuse me for next slide and disclaimer, being president of this limited liability company, I should add this presentation. But on the fourth slide, I am starting this presentation with this history. Can you imagine that 20 years ago, you can see, this is International Journal of Hydrogen, 2002, you got a chart where at first, and this is a very nice remark, that we've been, as a mankind, already utilizing renewables, biomass. It was in 19th century, even without coal, even without crude oil, nobody that time understood energy fusion or even hydrogen. 20 years ago, we've got such expectation that hydrogen will be, after crude oil, after natural gas, the source, the bridge for new energy we've been expecting, we are expecting, but nobody knows what will be the energy of the future. And on the next slide, you've got very short definition, and maybe it's worth to underline that today, as a mankind, being on Earth, there is no problem with raw material. At first with coal, lignite, but there is no problem with natural gas liquids, where we've got our propane, our butane as a part of this structure. And on the right-hand picture, you can see those structures where you can see C as a coal and many molecules of hydrogen somehow trapped on Earth. And maybe it's worth to underline that the part of this natural gas liquids from the upstream is today mainly used as a raw material for petrochemistry, not only for transport, but as well for, as Walt for polypropylene, polyethylene production. On the next slide, what I would like to underline is the difference where we've got LPG versus natural gas in this liquid form, or even compressed natural gas, CNG, utilized, for example, today by cars in our city. This is byproduct of the main source of energy today called crude oil. From this barrel from bacon, you can see, for example, that slightly above 20% are those upstream raw material we can utilize directly, even without refinery. And this is the topic for next 10, 15 years, because we should remember that being in Europe, we've got refineries and LPG as a part of the production, but there are many steam crackers, those huge installations where we can utilize raw material as our propane to propylene, then to polypropylene directly. And this is not a source raw material for transportation. I've started with this information that natural gas liquids with hydrogen, and hydrogen will be the bridge for the future, for energy, where the next generation will be ready to utilize. For those who are not so close to industry, but for those who are looking for broader picture, I am on next slide showing two books prepared by Michio Kaku, and with this beautiful quotation where we can find that in our century we harness the power of the stars. Yeah, and it will be the future when we can utilize hydrogen, like on sun, to helium during this fusion process. Today, the process seems to be controlled on Earth by 18, 20 seconds already. It means we can utilize this huge amount of energy on Earth as well. And it is our possibility. So fossil fuels, propane, butane with hydrogen will be the bridge for next era, for this fusion, nuclear fusion. I'm expecting to be the source of energy in the future. On the next slide, I am underlying that in Central Eastern Europe, not only in Germany as well, today we've got huge problem with natural gas deliveries. With this price level we haven't expected, with this problem with deliveries with LPG, you've got those information from Sibur, from Russian enterprises, that we can't expect proper deliveries even during next winter, in spite of the fact that we've got new technology, as my colleagues mentioned, and I'm once more underlying that this shale revolution, because shale gas, shale oil opened new position for those materials, especially for natural gas liquids as a byproducts of crude oil for us. On next slide, I am showing LNG and the product which today somehow I am utilizing this word push, but we can say that our expectation 10, 15 years in Europe was that the main infrastructure for natural gas, it is a pipeline. For refineries products like diesel, like petrol, pipeline seems to be the best source, the cheapest infrastructure we can utilize. And today, when we've got LNG as a commodity, simply commodity like banana, like gold, we can say, we understand that not only infrastructure, you should prepare your product, but not only infrastructure is the key element of the industry. I'm addressing this in such a way because on the next slide, I've got few pictures with once more methane as a clatrate, hydrate methane underwater. Shale revolution 10 years ago opened new possibility of raw materials on Earth. Methane hydrates we can see everywhere, mainly oceans, not in Europe, of course. But when we are talking about the possibilities, of course, there's not efficient technology for such production of those clatrates, methane clatrates. What I'm going to say is that it could be a possible source of energy, like for those in 18th, 19th century who didn't understand crude oil. Today we can say that we can't still understand how to utilize this methane in such structure. And I would like on next slide show that there is no problem with such understanding of hydrogen. Maybe it's worth to underline that the first patent license for hydrogen engine was issued in 1912, and till today we do not utilize this patent perfectly. Nobody can say that we've got today on Earth generator on pure hydrogen, which we can utilize in this efficient way. What does it mean? It means that we understand what hydrogen is, that we've got the knowledge, we've got resources, we've got plenty of documents, books, etc. And on the next slide, we've got this information that we understand what hydrogen is, how we can compare this to another resources like even helium, like even, as I mentioned before, propane or butane. Such understanding we've got. The only thing we do not have on Earth is a proper, efficient technology, how to obtain this pure, you said, green hydrogen without CO2 emission efficiently. And main message I would like to give, I would like to share, is that at first, as a mankind, as being human with this proper technology, with this hydrogen properly prepared, means that we are thinking about this source and we've got a problem how to obtain this in efficient and proper way. On the next slide, few words where I am convinced that hydrogen can play this major role in transformation. Of course, because of this enabling large-scale renewable energy integration and power generation. For sure, this is a possibility for storage of energy. From my perspective, from my knowledge, is that especially, for example, graphene could be a source where we can store hydrogen for our cars. And it could be, should be, a very clean feedstock for industry, for petrochemistry, for heavy chemistry, where we've got this fertilizers, for example, production. The problem is, and this is the next slide, that we've got a problem with cost of the technology. It is a very good document published 2019, prepared for G7 meeting in Japan. Japan seems to be the first, not only because of methane flat rates, as I mentioned, but also ammonia, we'll be talking about later on, but a country where they are verifying variety of technologies. And today, the problem is that the cost of production of this green without CO2 emissions hydrogen is too high. For example, when we compare this with the cost of CO2 emission, so this price should be more than 300 euro per ton to find. It is, of course, average, depend on technology, etc. It's no time for such reflection. But even today, when we've got over 60 euro per ton, it means that for five times higher price for CO2 emission should be somehow implemented to compare the technology of hydrogen hydrolysis of CH4 as well, could be utilized as an efficient one. Next picture showed the cost of decarbonized gas. And you can see that even biomethane, even electrolysis, hydrolysis, it is still not so efficient. And our expectation, having on mind learning curve, having on mind future, is that it should be somehow cheaper. Without cheaper technology, our achievement, our position in the nearest future could be very difficult. I am underlying this because next picture I'm attaching and I am underlying once more that this is a policy and regulator problem, because we are in front of Fit for 55 in European Union. We are in front of this taxonomy implementation, very close to this new regulations, and without understanding that today technologies we are going to utilize are costly. The prices for raw materials seems to be too high compared to other. We need to be very, very careful, having on mind those rules and regulations. On the next slide, I'm showing documents where you've got examples of infrastructure, because, and I mentioned that our expectation 10 years ago, 15 years ago, was that pipelines for natural gas. Today, pipelines for hydrogen. This is not the same story, and difficulties we've got with this hydrogen and implementation of such technology seems to be huge. I'm showing this to have this on the table, discussing the topic concerning new raw materials for the industry.
Andrzej,
yeah, I'm finishing right now because the next slide is showing only logos who is engaged, and I would like to ask: are you already engaged? Maybe yes. And on the last slide, this is the one word concerning AdBlue. We know we can utilize as a add source for diesel, but green ammonia, but this NH3 you've mentioned before, compared to propane, compared even to water, seems to be the future and possible source of energy, especially to this power to X projects. I would like to stay with this sentence and this slide right now. Thank you very much for this possibility, and I am open for questions as well.
Andrzej, thank you very much. Again, the wisdom there in understanding the whole hydrogen issue. You mentioned that it's too costly now. Let me just ask, because it sort of seems more relevant to some of the synthesis power to X, as you mentioned, that can produce LPG. Are you hopeful? Are you confident that if you take electrolysis to produce green hydrogen from turbines and solar, are you confident that electrolysis technology will get down the cost curve, or do you feel it's not going to happen?
Yeah, and my answer is very simple, that I am not expecting that it is a proper technology. Of course, we do not have other technology we can utilize right now. And when you've got this energy, electricity, we can utilize for, let's say, this minimum level of cost, it is kind of a possibility. But we are looking for new technology, how we can obtain pure hydrogen from ammonia, from water, from CH4, methane, natural gas liquids. And this is the reason that we need to open our minds and once more looking for new possibilities.
Great. Andrzej, thank you very much. I think we could have, in all the presentations so far, we could have easily spent an hour and a half on each individual one.
Excuse me.
Unfortunately, we don't have that time. So really, really thank you. I mean, lots to think about from your articulation of where we are on hydrogen. I'd like to move over now to yet another doctor, Dr. Chrisakis. Dr. Chrisakis is a business development manager with DNV Maritime. He has had a tremendous tremendous career in technology and research, focusing on energy efficiency and alternative fuels. He's also worked as a national technical researcher at the University of Athens, and he has both an MSc and a PhD. Also, the PhD was from the University of Michigan. So not only very learned, but also very experienced in more than one geography across the world as well. DNV have a tremendous position in the marine sector, as we know. We've talked from Cedric about energy transition pathway. It's been reinforced looking at all the other fuels that we could have in the future. Andrzej has given us a very clean and clear overview of hydrogen and what we think we need to do with hydrogen. Here, DNV are excellent forecasters, and also they have a lot of material and data related to the marine industry, so it's real. This is where new molecules are kicking in, and so it'd be great to hear the story from Christos. Thank you, Christos.
Thank you, Neil, for the introduction. I would like to, maybe while the slides are being uploaded, I would like to say a few words about DNV. We have a very long history in maritime. As Neil said, it's more than 150 years. We're the Norwegian Ship Classification Society, but we're also very much involved in oil and gas and power and renewables. And energy being related to most of our business. We have started issuing something called the Energy Transition Outlook. We started 5 years ago, so that's the 5th annual report. It's published in September every year, and it's actually a family of reports. And this has changed a little bit now. It used to be a little bit different before, but now we have it as you see it on the screen. We have the main Energy Transition Outlook. We have something called the Technology Progress Report, financing the energy transition that is coming out these days. We have the Maritime Forecast, and a month from now, we'll have the Pathway to Net Zero Emissions. That's the week before COP26, to talk about solutions for reducing our greenhouse gases. But let's start with our current forecast. So what we see on the next slide is our methodology, we're looking at big trends. We're looking at population growth, economic growth, energy use, technology development, and policy developments. And we realize the world is not a uniform place, so we split it in 10 regions, and we look at these trends in every region. Then we can understanding of developments in each region. We can also understand the interaction between the regions in terms of transporting, for example, oil, gas, and coal, and other goods. So we can also translate that into demand for seaborne transportation. And actually data are available on each one of these regions. Now, in the next slide, you can see an example of this regional analysis that is also very relevant to the energy transition, and this is carbon price projections. And maybe I should say here that we try to do this as a forecast. We don't do a scenario analysis. We try to come up with our best estimate of what is most likely to happen in the period to 2050. So this is our best estimate as we see things today on carbon pricing in different parts of the world. And we see that the dark blue line is Europe. It has the highest carbon prices and they're expected to increase. We've heard about the European Green Deal, and there are actually some regulations that will impact shipping for the first time. But we also see that other parts of the world are starting increasing their carbon prices or introducing them, or they will do that in the near future. We see that some of them, they fall on top of each other. This is because we expect, for example, developments in China to be followed by other countries in the Asia-Pacific region. But overall, we expect that Europe will have the highest carbon price. Now, moving on to some of the main results from the report, what we can see on the next figure here is, if we move to the next slide, we can see with the light blue line, the GDP growth. We see a nice recovery from the pandemic in 2020. I don't know if it's very clear on the figure, but there's a quite significant impact of the pandemic in GDP. We see a good recovery, and we expect the long-term trend to be very positive moving forward. If you look at the green line, this is population growth, still growing, but not as fast as in the last 30 years. Our forecast is actually slightly lower than the UN forecast. And then where it becomes quite interesting is the dark blue line, the primary energy supply. This has been increasing steadily for the last 30 years. Again, the impact of the pandemic is, it can be seen here, but it's increasing very little towards 2030 and then start very slowly declining. But overall, we can say it's quite stable all the way to 2050. And this is a sign that we're using our energy in a much more efficient way. That's a trend we have already seen in developed economies for a number of years, and now this is becoming a global trend. And finally, if we look at the orange line going down, actually stabilizing this decade and then start declining, this is our CO2 emissions related to energy. So that's the good news. The CO2 emissions are going down, but there are some bad news as well that I will come back to. Now, if we analyze this primary energy supply, and we can see this picture in the next slide, we'll see that until now we had roughly a 20% share of renewable energy and 80% fossil energy. Moving forward, this is changing, and we expect a roughly 50-50 split by 2050. Now, if we go a little bit forward, we're going to see and analyze the fossil energy sources. We can see oil, coal, and natural gas. Oil is the red one. We believe we have seen the peak oil demand. There's a very big impact of the pandemic. We see a good recovery. We don't expect the oil demand level to go above 2019 levels. I know some other forecasts, they expect it to be a bit higher, but I think overall there's an agreement that sometime this decade we're going to see a peak oil demand, if we have not seen it already, and then we will start seeing oil declining. This is partly due to a slow recovery in aviation and also to increasing trends towards electrification of the automotive sector. This is already starting in Europe, starting in North America and in China. So we expect this to accelerate. The gray one is natural gas, and this is the big winner, we can say, here. It's quite stable, still growing a little bit, but actually staying quite stable all the way to the early 2040s. And this is because it's replacing coal to a large extent. And coal is the black line here, already in decline, and we expect this decline to accelerate later this decade and towards 2050. Now, if we put this all together, in the next picture, in the next diagram, what we can see is the CO2 emissions from energy. We have only run our model to 2050, and what you see beyond 2050 is an extrapolation. But if this forecast is correct, and this forecast is not just a business as usual scenario, it's much better than business as usual. But if this is correct, by 2029, we'll have spent all our carbon budget for the 1.5 degrees temperature increase by the end of the century. That means we cannot reach that target. And similarly, by mid-century, we're going to exceed our carbon budget for the 2 degrees temperature increase. And according to this forecast, we're at a 2.3 degrees temperature increase scenario here. We believe there are ways to go even faster, and this is part of what will be covered in our Pathways to Net Zero report that is coming out at the end of October. But I think this graph is telling us that pressure for decarbonizing our global industry is going to increase in the future. And of course, that will also move to the shipping industry. That is at least my main area of work. So I would like now to focus a little bit more on the shipping industry, and I will also talk about different fuel options and the potential of LPG there. So from our Energy Transition Outlook report, we can get an estimate for the seaborne trade demand in the future. So we can see the different shipping sectors, how they can grow or even decline. We actually see a small decline in the crude oil tankers and the bulk carriers because we'll see less oil and less coal being transported. But the gray area here is quite small, but growing quite significantly is gas carriers, both LNG and LPG carriers. So that's an important part of the picture. Now, this can also be translated into fuel demand for shipping. And this is shown in the next figure, where we can see one scenario. This is now, we have looked at a few different scenarios, and this is one scenario of how the energy mix could change for shipping. I have to admit this is probably a little bit too aggressive on the oil decline. So it might be a bit slower in the beginning, but eventually after 2030, oil will decline because we have certain requirements that shipping has to meet. But what we see in the market today is that there's a very strong growth, in particular for LNG, but also for LPG. And this is lumped together here. It's called natural gas in this figure. It's the gray area. It might be a bit slower in the first few years, but it's going to be very significant growth. And that's something that we believe will stay with us all the way to 2050. We also see the green area, that is the introduction of biofuels to comply with certain emission requirements. The use of electricity at the very top is quite small. It's mainly for shore power and very small vessels running on batteries. But in the mid-2030s, we see the potential for introduction of what we call here low-carbon fuels, and that can be clean ammonia, clean hydrogen, or any type of e-fuels, any type of renewable hydrocarbons, including MGO, LNG, LPG, and methanol. And that brings us to the question of what is the best fuel option. So if we're thinking about a good fuel, we have to think about several parameters. And without going very much into details here, what we can see is that fuel oil is a very good fuel in terms of its properties, but its environmental performance is not good enough. What we have available today is the three fossil fuels I have listed there, LNG, LPG, and methanol. And we can argue about the exact color of different boxes, but the main point here is that these fuels are maybe not as good as oil, but they're available today. They can be used today. but still their environmental performance is not exactly what we need. It's maybe good for a short period, but then eventually we'll have to turn into something else. And this is what is coming at the bottom of this table: bio or synthetic fuels, hydrogen and ammonia, and all these, they have to be produced in a clean and sustainable way, as discussed by the previous speakers. So this is going to be one of our challenges, how to make sure that these fuels can come to the market. I would like to show now some statistics from the market. If we look at new building orders, in 2019, only 6% of the vessels in the order book were with alternative fuels, and actually half of them were with batteries. That's very small vessels. And then there was another 3% roughly LNG. LPG was just starting. If we look at the 2021 order book, and this is numbers before the summer, all alternative fuels are growing, in particular LNG and LPG and methanol. In the next slide, I'm taking the isolated order books of 2020 and 2021 only, and looking at the top on number of vessels and at the bottom of gross ton of these vessels. So this is giving us an idea of the size and the fuel consumption of these vessels. And we see that already in 2020, we had 6% of the vessels ordered with LNG, 1% with LPG. But if you look at the size of these vessels, it was quite bigger in terms of gross ton. It was 20% LNG, 3% LPG. And that is a sign that these are big vessels with relatively high fuel consumption. So these are the vessels that were ordered last year. And this year, this is updated 2 weeks ago, these numbers are growing quite significantly. We see both LNG, LPG, and actually also methanol growing. LPG, for now, it's only going to LPG carriers. 100% actually of LPG carriers ordered today are with LPG as fuel. So it's a very interesting development. And we already have 10 vessels that have been retrofitted to run on LPG. I would now like to spend the last few minutes talking about the requirements that shipping will have to meet and what is going to be the role of different fuels. So it's not any longer only regulations coming from the International Maritime Organization that shipping will have to meet. We also have regional regulations like the European Union is introducing, but also we have expectations from cargo owners, from charterers. They have their own environmental requirements. And also we have many green financing products. We have banks assessing the environmental performance of their investment portfolio in shipping, and they have increasingly stricter requirements. So now there are requirements coming from all stakeholders, and they're actually they're going faster than the IMO. So in the next slide, we can see a typical scenario where you could have a minimum compliance. This is the line you can see on the upper right. This is a minimum compliance scenario when it comes to carbon requirements, carbon emission requirements, or you can have a more aggressive greenhouse gas reduction strategy. And you can see here how different fuels can help you and how far they can help you into the future. So MF here stands for monofuel. It's a conventional vessel that can take you in the best case, in this example, to the mid-2030s. If you had LPG, you go maybe to 2040, and LNG a little bit further to the early 2040s. And eventually you may be able to run on clean ammonia or clean methanol, or actually you could replace this LPG, LNG, even oil with their low carbon equivalents if these products become available. And that would allow these vessels to run without any modifications, just replace their fossil fuel with a renewable fuel and keep running with low carbon emissions. We have looked at many different scenarios of how this can be done, and we have made an assessment of both the business case. This is in the next couple of slides that I think, in the interest of time, we can pass on, but these are going to be available after the conference. The 7 different scenarios. In the next slide, you can see an overview of the total discounted costs. Maybe the only cause is that in 5 out of the 7 scenarios, the costs are very similar. And that means that there are different ways to achieve the same targets. One of the scenarios is including going from LPG to ammonia. And this is shown. Actually, one more thing we did is that, as shown in the next slide, we are looking at the technical requirements for building a vessel that is flexible enough to be converted to run on another fuel. Ammonia engines are not available today. They're expected to be commercially available by 2024. Engine makers are working on that. We're looking at how you can build a vessel that could be converted later to ammonia, and there are certain requirements there. And whether you start from a conventional design or an LNG design or an LPG design, there might be many different requirements. So LPG to ammonia is actually the easiest way from a technical point of view. And we know that some LPG carriers today are already interested in later being converted to run on ammonia. I would like to close this presentation with just a very quick overview of LPG as a marine fuel. It can offer greenhouse gas reductions of roughly 15% compared to fuel oil. The propulsion engines are already available. The first vessel was converted a year ago. Now there are 10 vessels converted, and we have some new buildings that will be in operation soon. It's lower investment cost compared to LNG. There is global availability of LPG. It's a standard choice, as I said earlier, for LPG carriers today, and it is maybe the most suitable technology for an ammonia-ready design. So this is something that we see at least in the LPG carrier segment today. We start seeing interest from other segments on LPG as fuel. I think current LPG prices do not help to defend the business case, but moving forward, that could be one of the many solutions that shipping will need as a fuel.
Christos, thank you. I will be beaten up by Ava for failing miserably to keep everyone to time.
This was the last thing I had to say.
Okay, thank you. But it will be worth the pain because it's been absolutely tremendous from all 4 of you, and thank you for that. We have many questions. Again, I'll apologise to Paul Westerman. I'll put one of his questions, just one, which says, and it's for yourself, Christos. It's a very good question, actually. He says, well, I can actually put it up. There you go. He says, with the view that carbon will go up by 3 times in Europe, what's your view on GDP for Europe with that type of cost pressure happening within the European arena?
The impact on GDP.
Yeah. Just a view.
That's not an easy one. I would like to have the opportunity to look at our detailed report and what our projections are saying there. But in general, we expect GDP to grow globally. There are regional differences. I think it's growing for Europe as well. Obviously, high energy prices can have an impact on this. I think it remains to be seen a little bit how we handle the energy transition. What is going to be the cost of, because now we have also quite high carbon prices that make coal less attractive. They make natural gas more attractive in a way, but then this is putting a lot of pressure on using natural gas, and this is pushing prices up again. So,
sure.
I don't know if I have a good answer to that.
No, it's quite a complex question, really, to be able to give a snap, knee-jerk reaction to and an answer to. We have many questions. We'll try and somehow get these answered. All I would say is thank you very much. I mean, a couple of points that I picked out. Hydrogen is very versatile. It's at the moment too costly. We need to find a way of accelerating our costs down the product stack, as it were, to use it in many other areas. It's nice that, Christos, you went all the way through to the end of the century, but it's also, it's a little worrying that we could go over that 1.5 degree ceiling that we've set ourselves. Great message from Walt. You know, again, what it's interesting is that LPG is here to stay from Walt's information. The question is, what do we do about it? And the question is, what do we try and encourage regulators to allow us to do about it? Green hydrogen is the way at the moment. My question is simply, is there a way where we can use blue or grey hydrogen utilising LPG as a feedstock? Just leave it there. And of course, you know, Cedric showed us that from a member point of view, we're trying to get at the energy transition pathway because we want a sustainable future for our customers, but we also need to build a sustainable business. And when you look at some of the new molecules that Christos showed us are being used in the marine area, there is a future, but it may mean we have to be more flexible as an industry to embrace some of these new molecules. Thank you very much, gentlemen. Delighted to moderate the panel, although I failed on time. And now I'm going to pass you over to Eva. Eva.
Good afternoon, and thank you, Neil, for this extremely interesting session. We indeed received a massive amount of questions to all the speakers, and we will try to address those questions in due time. Unfortunately, we ran out of time to address them today, but it also shows how interesting the discussion is and how many people are interested in your thoughts and views. And what a day! And it finishes with extremely interesting session. And thank you very much once again to all the panelists for joining. Today we had an immense amount of information about LPG, about future fuels, about technologies and new technologies where those fuels can be applicable, about marine fuels, about renewable LPG. So we had an immense amount of information, a lot of this to digest. And moving tomorrow, I would really, really love to see you all coming back. And I think Neil, at the very beginning of his intervention, mentioned that, you know, we are here to learn from ourselves, and that's why we have a lot of internal information and a platform where we can actually communicate with each other. And I would invite you to join those platforms and to get to know other participants. But also we are here to learn from others. And tomorrow is a lot about learning from others. We'll have super interesting session which is going to outline how other industries are dealing with the decarbonization agenda. This is something for us to learn from and take back home and think about and digest. So I really, really invite you to join tomorrow morning. The session will be preceded by the intervention from Maria Malmqvist from Sweden, who is also our vice president. And I'm really looking forward to her take on those 2 past days of discussions and conversations. And finally, for those that are unable or were unable to join us so far or joined 1 or 2 sessions, we wanted to make sure that you don't lose the main messages. Hence, at the very end, in the afternoon, we'll have 1 more session where we will try to bring back all the key messages and key learnings that we've learned in the past 2 days. So I really, really would like to see you all tomorrow, and I look forward to the last day, but very, very exciting day as well of the European LPG Congress. Thank you so much and have a nice afternoon.